Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 3, Lesson 4, Dividing by a One-Digit Number. As we learn long division, I will be helping connect us back to the different ways of modeling that we learned in our last lesson. I'll be using area models and a little bit of color coordination. It's tempting to think of division as only learning a series of steps, but instead I invite you to think about it as a synthesis of many important math ideas. So let's take a look at our first problem. At a carnival, 6,381 apples are given out to children. Each child receives 3 apples. How many children are at the carnival? On my area model, I know that the grand total of apples is 6,381, like this. I also know that each kid gets 3 apples. So I know that of this area model, the side length right here is 3. The divisor is the number of groups that you want to divide things in. And that leaves us with the answer. The answer in a division problem is called a quotient. We will be building it right up here above our problem, but we will also be figuring it out using place value to find the side lengths of each one of these parts of the area model, like this. The quotient, the number we're trying to find, is equal to the number of children. So let's count and divide some children and apples. As we practice with our models, it's easier to pass out the bigger stuff. So let's just pass out 6,000 apples. 3 times 2 gets me to 6,000. That means I'm passing out 6,000 apples to 2,000 children. Once I've passed out those 6,000 apples, I will have 381 apples left. Let's go ahead and pass out some apples to some hundreds of kids. I'm in the hundreds place right here. 3 times 1 equals 300. So if I pass out 300 apples, they will go to another 100 children. So far my quotient is 2,000s plus 100. So I've taken that many apples away. How many apples are left? I've got 81 right here. Let's move on and see if we can pass out some apples from the tens place. 3 times 2 equals 6 tens, or 60 apples that I could pass out to 20 more children. So far I know that we've got 2,120 kids at the carnival. But when I do the subtraction over here, I discover that I am left with 21 apples. There's more dividing to do. I haven't had to do a lot of regrouping yet, but I'm going to do it now. By counting those 20 apples as single ones, I'm able to find out that 3 times 7 equals 21 apples. Now, that means a couple of things. First of all, it means that there were another 7 kids at this carnival who got those 21 apples. And also, there are no more apples left over, so I must have found my quotient of the number of children. One way that we love doing it this way is you can see that our quotient has been built for us up here just above the dividend and the divisor. But just to help map this out for you, we had 2,000 kids counted with these 6,000 apples, 100 kids counted with these 300 apples, 20 kids counted with these 60 apples, and 7 kids counted with these 21. When I add them all together, we are left with 2,127 kids, just the same as it is up here. That last problem had no remainder, but let's take a look at one that will. When 6,100 is divided by 8, the quotient is blank, that's our first question, and the remainder is blank, our second question. Considering our area model, we know that this side length right here will be 8, and we know the total number of things, and you can imagine them as anything you want. Donuts, puppies, birds, cicadas that are chirping outside my window right now. We know that there are 6,100 of those things. What we do not know is this side length, and we will find out this side length by taking it in steps based on place value. Once again, we will start in the single thousands place where, do you see that? 8 is larger than 6. 8 times 1 is 8, but we don't have 8 thousands. That means we're not going to have any single thousands in our quotient. So we know that this right here is 0. Now I have written it up here, and you are welcome to do that, but you don't have to. If you want, you can just leave it blank. One thing I know for sure, though, is that I'm going to have to do some regrouping in the hundreds place. I'm going to treat the thousands as hundreds, and I have 61 hundreds here. 8 times something gets me really close to 61. 8 times 8 is 64. I love square numbers, so that's easier for me to remember. But I don't have 64, so instead of 8 times 8, I'm going to go with 8 times 7. 8 times 7 is 56. That means that I have now taken care of 700 in each of my 8 groups. And when I put 700 in each of my 8 groups, I will get rid of 5,600 or 5,600 of whatever my things are. So let me see, I'll do a little subtraction here. 61 minus 56. If you wanted to cross out and do some subtraction regrouping there, you sure can. 11 minus 6 is 5. And 5 minus 5 is nothing. Yes, you can write a 0 there. I will not be choosing to. We figured out that each of our 8 groups will get 700 things. Now it's time for me to divide my tens place. And I'm going to regroup here and treat these 500s as 50 tens. 8 times 7 equals 56, but I only have 50. 6 times 8 is 48. So if I gave 6 tens or 60 to each group, I would take away 48 tens or 480 of them, which would leave me with 20. Now, yes, I could do some subtraction regrouping here, or I could just think to myself, the difference between 50 and 48 is 2. It's only 2 away. So you can use that kind of knowledge when you're dividing as well. Which brings us to our single ones place. Once again, this circle will help me remember that I'm not treating this as 2 tens and 0 single ones. I'm treating it as 20 single ones. 8 times 2 is 16. 8 times 3 is 24, and that's more than I have here. So I'm going to put 2 more of the things into each group, leaving me with 4. Just to show it one more time, if I take this 700, this 60, and this 2, and add them all up, I find my quotient of 762. But now I also have a remainder. What to do with it? Well, sometimes you just want to put it up here. We write the letter R for remainder, and then we would write how many are left over. If the things you were counting here, the 6,100, were pizzas or cakes, you might not want to just say, we got 4 pieces left over. Instead, what you might want to do is say, 4 divided by 8 is a fraction. There's a huge relationship between fractions and divisions. If I simplify this, I'll have 1/2, and that means I can put another 1/2 into each of my groups. So each of those 8 groups would have 762 and a half. If I was counting these 6,100 things as donuts that I wanted to put on plates, and there are 8 donuts on each plate, and I don't want any of my donuts to be left out or thrown away or just sitting on the table, I might even use this remainder to round up and say, I'm going to need 762 plus 1 more plate to put all my donuts on plate. So in that situation, I might choose to round up. Hey guys, thanks for playing division with me. I love playing division with you. Bye-bye for now.